So last year when they first did this, one of these Ignite sessions at NCSM, I made the mistake of saying to Jim over here, you didn't have an elementary person on the docket. Don't talk to Jim when we're finished. So anyway, I thought we might do some math. And this is from my experience as a 5th grade teacher. So I want you to think about how you might solve this problem. You may use the algorithm or not. But in just a second, when the slide changes, we're going to talk to you about, can you guess how most 5th graders would solve this problem? There it is, so you don't forget it. But most 5th graders are going to change $40 to $39.99 because you cross out the zeros and you make them a 9. And then you subtract. My question is, what happened to the penny? Then we come to multiplication in the 5th grade and we have the no-purpose 0. We teach them how to multiply step by step. So if I am multiplying by 30, I have to do 0 times 3, 0 times 9, 0 times 3. And for some reason, when I used to point that out to the kids, they had no idea what I was talking about. We think we need to, aha, I have an elementary school teacher there. So I want you to all read that problem out loud. And how many of you say 9 goes into 27? Then we have the infamous reducing fractions. What happens when I reduce a fraction? It's losing weight, so it's going to get smaller. So what happens? It just gets a little smaller. And then we have the kids who understand how to reduce a fraction and change 15 25ths to 3/5, but they get this idea just like, I love Lucy. There she is, reducing that. Even though it's 3/5, 3/5 is still smaller than 15 25ths because it has reduced. Most of my students didn't remember I Love Lucy. I stole this one from Glenda Lappin. I taught Stripe how to whistle. I don't hear him whistling. I said I taught him. I didn't say he learned it. We teach really hard, but that doesn't mean the kids always learn it. And then there was the year that I had all the 5th graders, and the next year I got promoted to the 6th grade. So I put this problem on the board expecting all the kids to be able to do it. And what did they write? 3/5. And I said, who was your 5th grade teacher? And they all said, you were. What concerned me, however, and what I learned was that I hadn't taught the kids any number sense about what those numbers meant and why 3/5 was not a reasonable answer no matter what they were thinking. So we had some conversation about it, and I kind of wished I could go back and teach 5th graders again. I think most of you know what your kids would do with this. They're going to come up with 3 3/4, of course, because you always have to start with the fraction instead of really teaching kids to think about what's 5 subtract 2, and then let's take off another 3/4. And then we have this whole notion of communication. Yes, ma'am, I understand you want me to give you more than just the math answer. You want me to explain how I got it. I copied it from the kid in front of me or behind me. I used to give my kids extra credit for bringing in math cartoons. And then we have this idea of when you add fractions, you need a common denominator. When you subtract fractions, you need a common denominator. But when you multiply fractions, you just multiply them both. What about some thought about changing to a common denominator and multiplying fractions? Just something I've been thinking about. Watch your language, the word canceling. Sorry, Phil, this one bothers me. That when we just have kids crossing out numbers and changing them around and calling it canceling, as if by some magic, rather than factoring, we can now just cross out numbers and change them and come up with the answer. Then we have the immortal, ours is not to reason why, just invert and multiply. The problem is, which number do I invert? I can remember I changed one of them. Would it make more sense to think about how many 2/5 can I get out of 4/5 and relate this whole notion of dividing fractions to division of whole numbers, rather than teaching kids all of these rules, and then when test time comes, I have to figure out which one works for which number. And then finally, decimals. I love decimals. When you multiply decimals, you have to count up the decimal places, and that's the number you put in the product. But when you divide decimals, everybody do it together with me, you just go like this. And there's no sense making. And then we have formulas. We start introducing kids to formulas in 3rd grade. We have length times width times height. We have length times width. We have 1/2 a times b. We have 2 pi r. We have pi r squared. We have half ab. We have prt. We have rtd. We just have all these wonderful formulas. Okay, let me see if I've got these area formulas memorized. For a triangle, it's 1/2 bh. For a trapezoid, it's 1/2 the quantity a plus b times h, and for a circle, it's pi r squared. Yes, yes, you've got it. Now I'm going to make $10 because you're going to pass the test. But I always get confused. Does the H stand for the triangle's height or my height? And I think we do that. So, what I want to conclude with is everything you do in math should make sense to you, except trapezoids. Thank you very much.